Okay, so we have Chapter 7 or Module 7 of Switching, Routing and Wireless Essentials, DHCP. Of course, version 4 for IPv4. So we'll look at implementing DHCP version 4 to operate across multiple LANs. And so we'll look at how it operates on a small to medium-sized business. We're going to look at how to configure it on a server, and we're also on a DHCP server and also on a DHCP client. So there's not a lot of slides, only 30. So concepts. So Dynamic Host Configuration Protocol, version 4 or DHCP, assigns IPv4 addresses and other network configuration information dynamically. Because desktop clients typically make up the bulk of network nodes, DHCP version 4 is extremely useful and time-saving tool for network administrators. A dedicated DHCPv4 server is scalable and relatively easy to manage. However, in a small branch or small office, home office location, a Cisco router can be configured to provide DHCP version 4 services without the need for a dedicated server. And so Cisco iOS software supports an optional full-featured DHCPv4 server. So the server dynamically assigns or leases an IPv4 address from a pool of addresses for a limited period of time chosen by the server or until the client no longer needs the address. Clients lease the information from the server for an administratively defined period. Administrators configure servers to set the leases to time out at different intervals. Typically, a lease is anywhere from 24 hours to a week or more. When the lease expires, the client must ask for another address, although the client is typically reassigned the same address. Actually, what typically happens is the client will start trying to renew the address as soon as it's halfway through its lease. But anyway, so DHCPv4 works in a client-server mode. When a client communicates with the server assigns or leases an address to that client. The client connects to the network with that leased IPv4 address until the lease expires. The client must contact the DHCP server periodically to extend the lease. This lease mechanism ensures that clients that move or power off do not keep addresses that are no longer needed. When a lease expires, the DHCP server returns the address to the pool where it can be reallocated as necessary. So what is the process of DHCP? So how does it go out? So of course, basically, a client boots, and once its network stack is up and ready and running and ready to go, it will see that it's set to automatically get an automatically assigned address, and so we'll send out a DHCP discover message. And so that's basically trying to discover if there's a server on the network that will fill its needs. And so if there is one or more servers, of course, they will reply with a DHCP offer. And so that actually has all the addressing information that they give out in that offer. And so then the host will choose the one it prefers, and normally it's the quickest one to respond is the one it prefers. And so we'll then send a DHCP request to the server saying, hey, I would like to accept this address if the offer is still valid, and so the server will then send back an acknowledgement saying yes, that is accepted, and so all is good. Now sometimes if that DHCP request takes too long, sometimes that address may well have been handed out to someone else as well, and so you might actually come back with a negative acknowledgement saying sorry, forget it, but that's pretty rare. And so that's the process. So DHCP discover, then an offer, then a request, then an acknowledgement. Now, prior to lease expiration, the client begins a two-step process to renew the lease, as shown in the figure. And so before the lease expires, the client sends a DHCP request message directly to the server that originally offered the IPv4 address. If a DHCP acknowledge is not received within a specified amount of time, the client broadcasts a DHCP request. I love that Motorola ringtone. And so basically, if there's no acknowledgement, it will then go back to the request process to find all servers. And so, of course, the acknowledgement just says, yeah, cool, carry on as you were with a new lease expiry time. These messages, primarily the offer and acknowledgement, can be sent as unicast or broadcast depending to the IETF. Okay, so how do we configure a Cisco iOS router to be a DHCP server? Now you have a basic understanding how it works and how it can make your job a bit easier. The Cisco router running iOS software can be configured to act as a DHCP server, and it assigns and manages the IPv4 addresses from specified address pools within the router to the DHCP clients. And so here we've got a Cisco router, and it's been configured as a DHCP server. And so, yeah, the clients can then request. They'll send out that broadcast, and the router will reply. And so it's actually very much the same as what your setup is at home, where your home broadband router is normally a DHCP server. Okay, so what are the steps? Now use the following steps to configure a DHCP server on Cisco iOS. Now the first step you're supposed to do is exclude IPv4 addresses. So basically, if there are addresses that are being used manually, statically, by, well, the router for one, and of course there could be switches and other servers and things like that, you actually need to exclude them. And so basically you're saying don't use these addresses. And so you're supposed to do that first, so that if you do it last, the server might actually assign that address to someone before you exclude it. And so, you know, that's why they say you should do it first. And so basically it's IP DHCP excluded address. You can just specify one address if it's one you're excluding, or you can do a starting and finishing address. So that will be a range basically. Then you do a command called IP DHCP pool and give it a name. So Fred, Harry, Mary, or, you know, LAN pool or something like that, a little more descriptive. And so, so that creates the pool and gives it a name. And then, of course, you need to configure other stuff as well. Now, the most important command in there is this network command. So you're in DHCP pool config mode, something along those lines. Yeah, you actually have to specify the network that this pool belongs to. And sadly, that's the one that seems to be forgotten most by students. And so this defines the entire addressing range. And so normally you need to specify the subnet that it belongs to. And so that's why you need to exclude the addresses first, because you then, when you do the network command, you're actually talking about the entire subnet. And then, of course, you exclude the addresses that are static or whatever it might be. So that's why you need to do that first. And then, of course, you need to define other characteristics like, you know, the default router and the DNS server. You can send off DNS names. You can do, of course, expiry for the lease, among many other commands. And so there are lots of other commands. We won't go through all of them, but also, even if Cisco doesn't actually have a specific command for it, there's a whole pile of option numbers that are available, and so you can actually define those as well. But I'm not sure how many of those are covered by Packet Tracer, but yeah, so that's basically how you all do it all in that config mode. And so here's an example of what you might do. And so as you can see here, we're in global config mode at the moment. IP DHCP exclude address, and so the range from 1 through to 9 for this subnet. We're also excluding 254. And so then we're creating this DHCP pool called LAN pool 1. The network command tells it what pool it belongs, what subnet it is. And so it's just the network number and its mask. Then you tell it who the router is, so default router 10.1. There's a DNS server that's on a different subnet apparently. And then you can also give it a domain name, and that's normally pretty much all you need to do. And you might need to put other things in as well, but that will depend on the setup of your particular network. So it uses the commands in the table to verify. So of course, show running config will actually have all of your IP config in there. Show IP DHCP binding actually tells you which host has got which IP address. Of course, it identifies a host by the MAC address because that's the only unique number they've got before they get an IP address. And then you can also look at statistics as well, and so that gives you overall statistics on what DHCP's been doing. Okay, now, so basically, as I said, show running config, so you'll see all the excluded commands, and then you'll see the DHCP pools defined, and so of course this is pretty much the same as what was in the other one. And then binding, of course, gives you a listing of the IP addresses and what hardware or MAC address, of course, is using it. And it also tells you the lease expiry date, which is well in the past. But anyway, and then the statistics, it just tells you how much memory it's using, how many address pools it's running, how many automatic bindings, and so on and so forth. How many discovery and request packets it's gotten. It's not a very busy server. Got to admit, I rarely look at that, but anyway. Okay, now of course, then you've got to verify on the host that it's got an IP address. So of course, ipconfig is the command on Windows that will tell you the IP settings, but it doesn't give it all to you unless you do /all. Funnily enough. And so the interesting piece of information here is the DNS server address, default gateway. There should also be a DHCP server address here somewhere. Yeah, sorry, there it is. And so that, of course, gives you a fair idea that, yes, DHCP is working nicely. Now, you can disable DHCP by doing no service DHCP. So you can sort of have the configuration there, but turn it off. And so then just turn it on when it's needed. It could be a backup DHCP server or something like that. Now, another thing is DHCP relay. Now, of course, by default, DHCP needs to be on every subnet that you've got. At home, that's not hard. You've only got one subnet. But, of course, in businesses, you will often have multiple subnets. And so businesses will not necessarily want to have a DHCP server on every subnet. And they might want some functionality that a Cisco router doesn't provide, or maybe they just prefer the GUI on Windows or whatever operating system it might be. But what you can do is you can actually set up the router to forward DHCP requests to a DHCP server. So in complex hierarchical network, enterprise servers are usually located centrally, so there's often a server subnet. So these servers may provide DHCP, DNS, TFTP, FTP, whatever services it might be. The network clients are not typically on the same subnet as those servers. In order to locate the servers and receive services, clients often use broadcast messages. In the figure, PC1 is attempting to acquire an IPv4 address from a DHCPv4 server, but of course R1 is not configured as a server. The server is on another subnet. Of course, routers don't forward broadcasts, and so it's not going to find that server. And so you can actually set up the router to be a DHCP relay agent. And so you can actually set it up so that it will actually translate that broadcast into a unicast. So you need to tell the router, well, what is the IP address of the DHCP server? And so you'd have to look down here and say it's 192.168.11.6. And so you tell that router, and then when it comes in as a broadcast, so destination 255.255.255.255, the router will actually rewrite that destination to be 192.168.11.6. And it will also put in its own IP address for the subnet it saw it on, so 192.168.10.1 as the gateway address. And so that lets the server know that, hey, we've got a request for a particular subnet. And so as long as there's a pool on the server that has that, and that's not hard to do, have multiple pools on one server. It'll forward it to the server. The server will then make the offer and send it back, and it'll all work nicely, and the host will hardly know that it's happened like that. So basically on the router you configure on an interface IP helper address 192.168.11.6, and so that is turning on DHCP relay basically. So you're telling it who the DHCP server is, and that's where it will send DHCP discover messages. And so you can actually, if you do show IP interface, it will actually tell you the helper address that's been set on it. Okay, so other service broadcasts relay. So you can actually do other services other than DHCP. Of course, DHCP and boot P are the most typical one, but you can actually do other things with that. Okay, so how do we configure a DHCP client? Not very tough. So there are scenarios where you might have access to a DHCP server through your ISP. In these instances, you configure a Cisco iOS router as a DHCPv4 client. And so sometimes Cisco routers in a small office or home office and branch sites be configured as DHCP clients in a similar manner to client computers. The method used depends on the ISP. However, in its simplest configuration, the Ethernet interface is used to connect to a cable or DSL modem. To configure an Ethernet interface as a DHCP client, you do IP address DHCP in interface mode, of course, for that interface. In the figure, assume that the ISP has been configured to provide select customers with IP addresses from this range, and so the G001 interface is configured as a client, and so boots up, sends out a request, it has a server and replies, and so the router will then get its dynamic IP address. So here's the example. Instead of doing IP address and specifying the address, you can just do IP address DHCP. And of course, no shutdown, you need to turn the thing on. And so it will then send out its request, hopefully get an address, and everyone's happy. And so if you do show IP interface here, it's got an internet address there, and it tells you that it's determined by DHCP. Okay, so of course home routers will often be in much the same situation, and so home routers are typically already set to receive IPv4 addressing automatically from their ISP. This is so that customers can easily set up the router and connect to the internet. For example, the figure shows the default WAN setup page for a packet tracer wireless router. Notice the internet connection type is automatic configuration DHCP. This selection is used when the router is connected to a DSL or cable modem and access a DHCP client, requesting an IPv4 address from their ISP. So of course, this is basically looks like a Linksys setup here. That's what Cisco normally shows. So of course, other routers will have a similar interface. Okay, that's it for the chapter. So a bit of a covering, of course. And so, so DHCP version 4 dynamically assigns or leases IPv4 addresses to a client from a pool of addresses for a limited period of time chosen by the server, or until the client no longer needs the address. So the lease process begins with the client sending a message requesting the services of the DHCP server, that discover message. If there is a server that receives the message, it will respond with an IPv4 address and possible other network configuration information. So, of course, that's the first two packets of the 4-lit exchange. The client must contact the server periodically to extend the lease. Typically, halfway through the lease, they will actually start attempting to renew their address. And so, of course, basically that means that they will never run out of an address, hopefully, as long as the server's still up. The lease mechanism ensures that clients that move or power off do not keep addresses that they no longer need. When the client boots or otherwise wants to join a network, it begins a 4-step process to obtain the address. So, of course, the client sends the discover message. Is there a server out there? Then the server will reply with an offer message. And then the host will send a request to that server it wants to get its address from, and the server will acknowledge saying, yes, cool, we're all good. Client, and of course, to renew the lease, it's just a request and acknowledgement, typically. Cisco router running iOS software can be configured as a DHCP server, and so basically you exclude the addresses, then you define the pool, and then you configure the pool. And so to verify it, you do show running config or section DHCP or show IP DHCP binding or service statistics. The DHCP service is enabled by default. To disable it, you do no service DHCP. Okay, so network clients are not typically on the same subnet as enterprise servers, providing DHCP, DNS, TFTP, and FTP services to the network. In order to locate the servers and receive services, clients often use broadcast messages. The router must be configured to relay DHCP messages to a server. And so that's done by using the IP helper address command. And of course, in the interface that it's meant to do it. So DHCP is the most common use for it, but there are other services it can support as well. To configure an Ethernet interface as a DHCP client, use the IP address interface configuration mode command. Home routers are typically already set to receive IPv4 addressing from the ISP. The instant connection type is set to automatic configuration, DHCP. So this selection is used when the router is connected to a DSL or cable modem and acts as a DHCPv4 client. And so it requests that from the ISP. Okay, there's the end logo. So that's it for the chapter. So yeah, we'll see you later.